Hi, this is the first example for uniform rod. Okay, look at the diagram. A rod is being sticked to the wall, so one end is fixed, and the original length of the rod is 1 meter long, and the area is 100 centimeter square. Okay, the elasticity is 200 gigapascal. Okay, and the other end of the rod is being stretched by a 12 kilonewton force. Okay. So the elasticity is 200 gigapascals 10 to the 9. Okay. Before we work on a problem, we want to switch all the all the units into a workable unit, right? So if you have meter, you cannot work with centimeters. So we change everything back to a meter. The area instead of 100 centimeters square, it is 10 to the -4 meters square. Okay, K, we had that we had that formula developed in the previous videos. It's AE over L, which is 1 times 10 negative 2 times 2. So our constant K is 2 times 10 to the 9. Okay, let's redraw that rod and simulate it with a spring element. First stop, first step, we name the node as 1 and 2. And the movement for 1 is U1, and the movement for 2 is U2. And it's called K1. Somehow F1 and F2 as well, times 10 to the 3 Newton. Let's rewrite the formula in matrix form. Next step, we're going to apply the boundary conditions on it. Okay, we know U1 is not moving, so we take that away and call it 0. And we know AE over L, we already calculate that up there. 2 times 10 to the 9. And we all know force 2 is a 12 10 to the 3. So we're going we're going to multiply the matrix F1 12 times 10 to 3 equals okay 0 times 1 and then negative 1 times 2 U2. That matrix turns to two equations. and then 12 times 10 to the 3 times 10 to the 9 u2. Therefore, we solve for the second equations. u2 times, 6 times 10 to the negative 6 meters. And F1 equal to, we always check with a free body diagrams. Now we know F1 is negative 12 times 10 to the 3. We check up there. We know F2 is 12 times 10 to the 3. So F1 is negative 12 times 10 to the 3 Newton. It makes sense. So we have a positive force and a negative force, so that thing stay in place. Thank you. In next video, we're going to show you how to do the problem in 2 elements. Thank you.